Hello, everybody. Welcome to today's Dynamics 365 Tech Talk. Today's topic is implementation guidance on Azure Machine Learning Service for demand forecasting. My name is Brad, and I'll be your moderator today. We are broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording will be available on the Tech Talks Community Dynamics page within 5 business days. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions throughout the broadcast and in the Q&A segment near the end. Thank you for your patience during these announcements. Presenting for us today from Microsoft, we have Nikhil Paldhikar, Senior R&D Solution Architect. Nikhil, over to you.
Thanks a lot, Vlad, and thanks everyone for joining us today. This is the second Tech Talk in the two-part series on demand forecasting using Azure Machine Learning Service. In today's session, we'll go over the implementation guidance on Azure Machine Learning Service. I'm joined here today by my colleagues, Toby James and Krupke and Andrey Garmash. In today's Tech Talk, we will first learn about Azure Machine Learning Service and Azure Machine Learning Studio. Then we will see a demo of setting up the Azure Machine Learning Service for demand forecasting within Dynamics 365. Next, we will go over the Azure Machine Learning assets and data processing details. We'll also see a demo on how to add a new forecasting parameter to the AML service. Then we'll go over the implementation guidance for the AML service. Finally, we'll end this session to spend some time going over questions that you may have. So let's start with our first topic, Azure Machine Learning Service. What is Azure Machine Learning Service? Azure Machine Learning is a set of cloud services for accelerating and managing the machine learning project lifecycle. The Azure Cloud Services, in conjunction with Python SDK, will enable you to prepare data for machine learning experiments, build, train, manage, and deploy models, run and track your ML experiments. Azure Machine Learning Studio is a graphical user interface for a machine learning project workspace. In the Azure Machine Learning Studio, you can author and edit notebooks and files. You can manage common assets such as data credentials, compute, and environments. Visualize pipelines authored through developer interfaces. You can view runs, metrics, logs, and outputs of your experiments. And you can train and deploy different models. Let's take a deeper look at some of the artifacts that we saw on the earlier slide, which are major components of the Azure Machine Learning Studio. First and foremost, important artifact within Azure Machine Learning Studio is a pipeline. A pipeline consists of a number of steps, which equates to a function that you define. Each step can be performed independently or as a part of single deployment command. As you see in the diagram, pipeline can have multiple steps. Through each step, you direct the command to perform various tasks, which in this example are tasks around data ingestion, data processing, model building, training, and finally deployment of the model. Next is an experiment. An experiment is a named process in Azure Machine Learning that can be performed multiple times. Each iteration of the experiment is called a run, which is logged under the same experiment. Next artifact is compute target. A compute target is a designated compute resource or environment where you run your training scripts or host your service deployments. This might be your local machine or a cloud-based compute resource. Using compute targets makes it easy for you to later change your compute environment without having to change your code. Last but not the least, a run represents a single execution of your code. A run is an abstraction layer around each submission and is used to monitor the job in the real time as well as keep a history of your results. A single run contains metadata about the run, such as timestamp, duration, etc. It also contains the output files collected by the experiment. Now that we understand the basics of Azure Machine Learning Service and the AML Studio and its artifacts, we'll move to the next section where we'll see how we can set up the Azure Machine Learning Studio as well as the Machine Learning Service for the demand forecasting within Dynamics 365 SCM. In order to set up the AML service for demand forecasting in Dynamics 365 SCM application, we need to ensure the prerequisites are met. Dynamics 365 SCM version 10.0.23 and later versions support the new Azure Machine Learning Service. One of the prerequisites for the setup is to enable the feature within your D365 SCM instance. The name of the feature that you will have to enable is Azure Machine Learning Service for Demand Forecasting, and you will find this feature within the Master Planning module. Next, we need to ensure that there is a valid Azure subscription available for you to set up the Azure Machine Learning Service. To enable Azure Machine Learning Service to process the demand forecast within Dynamics 365 SCM, you must set up Azure Machine Learning Workspace. In order to do that, you have two options that you can choose from. The first option is to run a script that will automatically set up your machine learning workspace. The script will automatically perform the necessary steps to set up various artifacts required for the machine learning service to be configured. The second option is to manually set up the machine learning workspace. In today's Tech Talk, we will go over the option 2 and see in details how to manually set up the machine learning workspace and the different artifacts. The steps that we will follow today are starting with creating a new workspace within Machine Learning Studio, configuring the storage, configuring a default data store, configuring compute resources required to process the experiment, and finally, we'll create pipelines that will have steps required to run demand forecasting within Dynamics 365. Over the next few slides, we will do a demo on how to set up the Azure Machine Learning Service for demand forecasting. In order to create the Azure Machine Learning Workspace, you need to go to your Azure portal and click on Create New Resource and select Machine Learning. On the wizard, you need to first select or create a new resource group. In this case, I'm creating a new resource group. Then you have to name your workspace. This is your Azure Machine Learning Workspace and will be called by that name. Next, you have to select the region. In this case, I'm selecting West US. Next is to create a storage account. This will be used as a default data store for your workspace. A key vault is used to store secrets and other sensitive information that is needed by the workspace. A workspace uses Azure Application Insights to store monitoring information about your deployed models. Finally, you have to create a container for your workspace. Once you enter all these details, you need to click on the next tabs and make sure that all the selected options are what you need. And then eventually you have to click on the Review plus Create button. This will start validating the inputs that you have entered. And once the validation is passed, click on Create. This will start the process of deploying your machine learning workspace and all the artifacts within the resource group that you have selected. As you see on the screen, you have your resource group within which all these artifacts are being deployed. The next step is to configure the storage within your machine learning workspace. In order to do that, there is a GitHub repo where you have to go and download certain templates for Dynamics 365 SCM, demand forecasting within Azure Machine Learning Service. We'll provide these resources with the documentation. You need to go to the folder that you downloaded and make sure that all the files are in the folder, including the sample input CSV file. Once you do that, you need to go to the Azure portal and go to the data storage account that you created earlier. Click on the containers and create new container with the name demplan-azure ML. Once the container is created, you need to upload the sample input CSV file in the container. This is the file within that template folder that you just downloaded. This file is required to publish the initial pipeline and generate a test forecast. Once you have created that, the next step will be to configure the default data store for your Azure Machine Learning workspace. In order to open the Machine Learning Studio, go to Machine Learning Workspace you created within the Azure portal. Click on the Launch Studio, which will redirect you to the Machine Learning Studio and to your workspace. Next, click on the Data Store button and then click on New Data Store. Enter the details in the wizard, starting with the data store name. Then select data store type as Azure Blob Storage. Select the right subscription ID. Select the storage account that you have created earlier. Select the container that you created in the earlier step. Finally, you have to provide an authentication key. This account key will be present on the Azure portal. So you have to go back to the Azure portal, go to your resource group, which contains your storage account. Once you go to the storage account, on the left-hand side, you will see the Access Keys tab. You need to copy the key that is present there so that you can enter that access key as the account key in your authentication. Once you do that, you need to create. This will create your default data store for your workspace. Next step will be to configure the compute. In order to do that, go to your machine learning workspace and click on Compute. Click on Create New, and you have to name your compute instance. This will be used to create the initial demand forecasting pipeline. Then select the virtual machine size that you desire. In this case, I'm selecting for the demo purposes the standard D2V2 compute instance. Then the next step is to create a compute cluster. Select New, select the right location where you want your compute cluster to reside, and select the virtual machine size. Again, I'm selecting the standard D2V2, which provides me with 2 cores. I'll give it a name, and I'll make the maximum number of nodes that are available, in this case, which are 3. These nodes should be more than 2 at least, and should be less than 11. Once my compute cluster is created, the next and the final step of this configuration is to create pipelines. You had downloaded the templates folder from the GitHub repo. You need to look at the folder structure of the templates that you downloaded, and you will see there is a SRC folder and a R entry script folder. You need to create a similar structure in your workspace under notebooks. Under notebooks, you'll see a folder with your username. Create a new folder under that, name it SRC. Once you create that folder, you need to upload the 3 files that are in the SRC folder of the templates. These 3 files are API trigger, parameters, and run. Once you upload these files, The next step is to create the R entry script folder within your SRC folder. Now you need to upload the forecast.r file in the R entry script folder. Once you complete these steps, your folder structure is ready and your files are uploaded. The next step is to edit the parameters file. So click on the parameters file. Here you have to provide a node count and the cluster name. The cluster name will be exactly what we created on the compute cluster. Check the number of nodes that are available, which is in this case, there are 3 nodes. We have to reduce the node count by 1. So we will have node count equal to 2 in our parameter file for this example. You need to make sure the node count is more than 1. Then you need to go to API trigger and run that script. This script will create the pipeline, the first pipeline that will run your forecast for the sample input file. You can go to the experiments tab in order to check that there is an experiment that has been created after we ran the script, and then the pipeline tab to see that there is a pipeline that is created and it is running. Now your machine learning workspace is ready and it's ready to run your forecast. Next step is to integrate your Dynamics 365 SCM application with the AML service that you just established. In order to integrate the AML service with Dynamics 365, an Active Directory application is required to authenticate with the resource that are dedicated to demand forecasting by using service principal. You need to register a new application in your tenant's Azure Active Directory. Once the application is registered and the client secret is generated, you will have the tenant ID, the application ID, as well as the client credentials, which are the secrets that you have developed. Go to the secrets and ensure that you copy the value of the client secret and note down with you because you will not be able to retrieve this again. Now you have to go to your Dynamics 365 application. What we are doing here is we are going to the master planning module and the demand forecasting parameters form. Here you will see the Azure Machine Learning Service tab, and you have to provide the parameters that we just created. The tenant ID, the application ID, the service principal secret, which is the value, and the storage account name. Finally, you have to also provide pipeline endpoints. You can find that in your workspace. Once you go to their workspace, you need to go to the pipelines. Within the pipeline, click on pipeline endpoints, open the endpoint, and copy the REST endpoint that you see there. This is the endpoint that you will copy within your Dynamics 365 application in the parameter called pipeline endpoint address. Once you complete this step, save your parameters, and your Dynamics 365 SCM application is ready to be integrated with your AML service, and you're able to run your first demand forecast. Next, we'll take a look at the architecture and assets and data processing details for the Azure Machine Learning Service for demand forecasting. I'll pass it over to my friend Toby, who is going to take over from the next session.
Great, thank you, Nikhil. So in this section, we're going to take a look at the overall architecture of the demand forecasting solution. I will dig into the forecasting template a little more and also take a look at the makeup of the input and output files. So from an architecture perspective, we essentially have these 3 components. We've got Dynamics 365, which is responsible for some pre-processing of the historical data. It will trigger the forecast, and a user will initiate this whole process before it presents the forecast back to the user in the UI for further processing. We have Azure Machine Learning. This is where most of the smarts happen to generate the forecast. We've also got Azure Blob storage. Using container storage, it will persist the inputs and outputs as well as the logs. So if we step through the end-to-end flow, we've got a user who is initiating the historical demand, or initiating the forecast, I should say. Part of this is collecting the historical data and then persisting that to blob storage. When that historical data is persisted, Dynamics 365 will trigger the AML experiment. Now, initially, AML is going to prepare the data inputs, and it does this by partitioning the data by granularity attribute. And it'll store that partitioned historical data in a Parquet format in Blob Store. And once that data pre-processing is completed, it's now time to generate our forecast. So for each granularity attribute, a work process will be created to generate the forecast. Then once all the forecasting has been completed, those forecast results are combined and will persist back to the Azure Blob storage in a single output file. Control will then passes back to Dynamics 365 where that forecast is ingested, and then the user can review, adjust, and authorize the forecast. So for the next few minutes, I want to focus on some of these components. We'll look at the demand forecasting template. So this includes the scripts and related assets to run the forecast. I will also take a look at the schema of the input and output files. So from a demand forecasting template perspective, you recall in Nikhil's demo how he took us through downloading from the Git repository and then uploading those files into AML Studio. So we've got several files here. The parameters file, again, Nikhil took us through this, so I won't go into this in any great detail. Probably the one we didn't go into was the timeout in seconds. So this is going to provide a way to stop the forecast if it's running for longer than what we expect. Obviously, there's a compute cost. So if something is running longer than we would expect it to, we might want to stop that. The API trigger script, this is a Python script, which is used to create the pipeline endpoint if it doesn't exist. It should also be run after making any changes to the forecasting scripts. And as Nikhil mentioned too, it can be used to test the pipeline. So we'll use this in an upcoming demo to test some changes that we'll make. The run Python script, this is the main entry point that sits behind the API endpoint. And we also have the forecast R script, which is probably doing the most important work as far as processing or generating the forecast. Essentially, this is a wrapper calling the core forecast R package, as well as preparing the final output. A sample input file and the CSV file we mentioned that can be used for testing the pipeline endpoint. And this template is provided all through a Git repository on GitHub. So we'll look at the input and output files now. So this is the schema of the input file. Essentially, the input file are the historical transactions. So the granularity attribute along with the date key is the primary key for the record. Then for each, we'll have a transaction quantity. The forecast parameters, so these are set up in Dynamics 365, and we'll have one column per parameter in this file. And these will only be populated for the first row of a given granularity attribute. And if you haven't seen the first Tech Talk in this series, I'd highly recommend you watch the recording as we go through all of the standard parameters and what they mean. So it'll add much more context. The sample, the input file would look something like this. This is just dummy data, but it'll give you an idea of what it might look like. So from an output file, so these are the forecast transactions that get ingested into Dynamics 365. Again, we have the granularity attribute, the date key, that are going to make up that primary key for the record. For each of these, we're going to have a forecast quantity. Then we're going to have a confidence interval. Now, this is a value that provides feedback on how confident the algorithm is in the forecast. Typically, you see that the further into the future a forecast is, the less confident, obviously, given relative greater uncertainty as we project in the future. The error percentage MAPE or MAP-E is represented here. And then the forecast model name for the forecast is also output. So if you've specified a specific forecast model in your parameters, then this should match that. However, if you've specified all as an option where you want the algorithm to choose the best the best forecast model, then you'll be able to see in Dynamics 365 which one it chose. So this is output to the file as well. Because error percentage and forecast model apply to a given granularity attribute, they're only specified in the first row as well. So if we look at what a sample file might look like, it's something like this. So in this next section, we're going to take a look at how we might extend the standard solution that's provided. And the input and output files are important into how we go about testing this and validating it. So for this, before we get into making those changes, it's important to understand how we arrived at this point, where we need to make a change in the first place. So I'll talk you through this scenario here. The following chart that we've got shows our yearly historical sales for the past couple of years, as well as a forecast that we've done using standard out-of-the-box parameters, and the forecast is that blue line there. We did expect when we were doing our testing to trend at least to 2021 or be more, to be fair, we needed to be closer to 2020. We provided 2 years or over 2 years of historical data into the forecast. So if we look at 2020, our sales were at their highest at this point, and then throughout 2021, we had a rapid decline, though we did seem to maintain some sort of seasonality pattern in those sales. In 2021, in this scenario, the business was impacted by COVID, and more so the disruption to the supply chain, which meant that they couldn't stock enough product to meet that demand, which led to a decline in sales. But as they're looking into the future, they're seeing that actually 2021 is not very indicative of where they see their projection as the supply chain is opening up. They're expected to see figures closer to the 2020 sales numbers. So again, look at the forecast generated, that blue line. It doesn't really reflect that reality. The forecast algorithm has preferenced the more recent sales, which kind of makes sense because we, from an algorithm perspective, we're tending to look at what happened more recently as a better predictor as what will happen in the future. But for us, that's not all that helpful. So how do we solve this problem? So this is where the R package called Forecast comes into the picture. So this is an open source package that the demand forecasting solution uses. Out of the box, though, with Dynamics 365, we expose only a subset of the total available parameters. So for our scenario, we've determined that ETS is the best model for our products, but we need to put a heavy weighting across the more of the historical data. So we want to make sure that there's not just heavy weighting on the more recent data, but we want to go further back to 2020 as well. Now, this is where a data scientist with experience in forecasting can really help. Otherwise, through our research of the standard forecast package, we've determined that we can look at an option to extend what we've got to get closer to what we need. And this is where we find that the ETS function, which is part of that forecast package, has a parameter called alpha, which by default is set to null. And we can use this to our advantage. So alpha is a parameter of that forecast library. Within that, there's a function called ETS, and this refers to an ETS as smoothing factor. Now, the higher the value, the more weight is given to the most recent history, whereas the smaller the value, more of the history is taken into account when making a prediction. So this is much more aligned to what we need to do to influence our forecast. So for this scenario, essentially, we are going to be adding a new forecast algorithm parameter to Dynamics 365. And then most of our work will be done in modifying the R script. Environments and tools we'll be using, essentially an F&O instance. Can be a tier 1, tier 2, it doesn't matter. We'll use an AML workspace, AML Studio, and within that we'll use the native R script editor. We won't be using version control or setting up a CI/CD pipeline in this demo, but you can always do that as part of your development and application lifecycle management processes. So we'll get into the demo now. So this demo is really intended to show you what is possible. So don't be too concerned if you have no development or coding experience. In the demo, you'll see some sample code, which is really just provided for illustration purposes. The tools and process also used throughout the demo may not be the same as you would if you had a full-blown development process. Essentially, we're using this as an easy way to convey the main concepts. There is quite a bit of content in this demo, and at times it may go fast, but I'll remind you that we are publishing this recording. So in the next few days, you'll be able to watch it back and catch anything you missed. So just to reorient us, here is the chart that we use for comparison purposes. Again, the blue line is our forecast, and the other lines are our history. And this is important. We want to have a baseline for comparison purposes. So from here, let's get into making the changes we need to make. So within ML Studio, first, we're going to just duplicate the standard forecast.r file that's provided. And we'll open up the file, so the forecast file, so we can start making some changes. The first area I want to modify is the entry script, so the run function. This function is going to be called for each mini batch. And we'll scroll down to the bottom where we want to set our own parameter here. So we're going to create a new parameter called ETS alpha, or a new variable here. We'll do some basic checks, such as, we expect a number here. And then we should just default ETS alpha to null if it's not provided or it's not in the file as a catch-all there. So once we've got our variable, we want to start at the train models function. We want to provide this to that function, and then we'll just update the other areas of code that reference this function to make sure we're passing in that same variable. Edit here and down here. Okay, and then back to the start here. Now, the name says it all. We're only really interested in ETS. So we'll find where the ETS forecast is being generated, and we find this model ETS. So we know we need to provide it to this. And again, we'll go to this function and make sure it can accept this input. And then within here, we get to the standard or the ETS, the forecast R package, and we'll provide that alpha variable there. So that's pretty much it for the code changes we need to make. There's not a lot. It's pretty straightforward. So now that we've made our code changes, we want to test this. So I've got an input file here. I'm going to, we'll take a look at this first. I'm just using the Azure Storage Explorer to open this. And then we can see here, this is ETS alpha that we've added, and I've just provided a fairly low value there of 0.05. And we're forcing the ETS model. I'm going to delete this sample input file because I'll clone the one that I prepared earlier, and we'll just rename it to sample input. And this just saves me from having to change the script that I'm going to use to test this. So now we've got that. We want to invoke the API trigger. We're opening this. You can see sample input there, and we're going to run this one. Now, while this is running, it's going to provision our resources, it'll process our data, and then generate a forecast and output that as a CSV file. And once that is done, we'll go and have a look at the output file. This is just one way to access it. We're going via the run itself. We're going to click on that forecast run, and we'll show data outputs. And this will take us straight to the Azure portal, where we can see this output file, which is a text file in a CSV format. That's essentially our data. So what I've done is put this in Excel, and we can now see the yellow line here, which is our ETS alpha forecast, where we've specified the specific value of 0.02. And this is getting closer to what we expect. I mean, we could continue refining this or retesting with different inputs if we wanted to, but for demonstration purposes, we'll leave that one here because we want to run this end to end now. So going into Dynamics 365, and we're going to create the forecast algorithm parameter. And then let's get into running this. So we'll generate the statistical baseline forecast. And I've set everything up here. I am just filtering by the specific item allocation key that I want to test, which just has one item in it. and that will initiate the job. And this statistical baseline forecast generation history, it's a long form name, will have sort of all the different steps, and this is good to use to track the progress and see where it's up to. It's processed those first few steps pretty quickly. As I mentioned in the architecture slide there, before it calls the Azure Machine Learning Service, it persists this file. So I just want to verify here that, yeah, it's passing in that ETS alpha parameter and the value that I specified. Then we'll go back into the Machine Learning Studio, and we can see that this is queued, the forecast. And again, this is purely for illustration purposes. We could just wait for it to finish in finance and operations. And it's completed there. We'll just check that the data output looks kind of what we expect and not something different. So it is in the format, but we really want to get back into Dynamics to visualize this. And we can see that it's all finished there. And I now want to go to the adjusted demand forecast form. You can see all my forecasts are in those buckets there, and let's look at the forecast line details. See a nice graphical representation of our history and our forecast. We'll also see those values from the output file coming through into this form. So that concludes the end-to-end sort of extensibility scenario demo. So as you can see, I hope that's enough of a teaser to provide sort of context as to where the potential that you could, as far as where you could take this. From an implementation guidance perspective, we're going to focus on two areas, testing and performance. Testing is super important, as with any implementation. We want to start the process fairly early. So, in the early stages, before we get into design and build, we really want to start by formulating our test strategy. And this will include defining your scope and, starting to flesh out your test plan and making sure you've got well-established test management processes and all of that. If the demand forecasting implementation is being run in parallel with a broader new Dynamics 365 implementation, then you'll need to ensure that you can source the historical data early, because you won't have historical data in Dynamics 365. You'll have it most likely in a legacy system. So this is something that will be important to start early, is determining where you're going to source that and what sort of quality of data you can get. If you don't have history, you don't have a forecast, because this setup is really driven by the historical data. You won't need all items up front, and in fact, you probably, you don't want to start with your full product catalog. You probably want to start with a subset of items. So focus on those products that are better suited towards forecasting. So what do I mean by that? Some products might be highly volatile from a sales or transaction perspective, where there's no pattern or trend, or the data is quite patchy, and it is very difficult to generate an accurate forecast. So start with data that is less volatile, and then build up to more complex scenarios. And over time, you can build out that test data set. From a requirements perspective, you'll really want to define the non-functional requirements. These are things such as volumetrics, the frequency at which you'll need to be running the forecast. Do you need to run it daily, weekly, monthly? What are the SLAs that you're working to? So how fast do you need the forecast to run? Is it something that needs to run in a couple of hours, or can you do it over a weekend? That'll be really important input as you start testing this and configuring it. From a functional requirements perspective, they are important too. You may define these in terms of how you may classify your items for the purposes of forecasting. So how you group those, what you might determine as an acceptable make or that error range for those different groups of items. You also want to define what historical data you need to consider, such as, are you looking at sales orders, transfer orders, production orders, other types of transaction data. From an environment perspective, you want to identify and provision environments for your initial testing. Also have an indication of what you'll need for other test environments throughout the implementation. So if we've got a user acceptance testing phase, we may want to incorporate the demand forecasting in that. So what do we need as part of that? And licensing is important as well. So then looking at the different types of tests, we've spoken about the importance of validating historical data early. Sourcing it first and validating is important. But you can start fairly early with some unit and functional tests. As I've shown in the demo, you can even start, if you don't have Dynamics 365 fully configured, you could even start direct with Azure Machine Learning Studio. But then as you start to configure Dynamics 365, it's a good idea to make sure you're getting in those sort of process tests and end-to-end tests so that you can see how the solution is coming together from an end-to-end perspective. So from if we look at end-to-end testing as an example, you'll need to, you'll want to test that it's, if we're creating sales orders in Dynamics, that data is flowing as we expect it into the history. And also, as we get to the other end where we've got a forecast, how does that data then flow into your MRP processes? So that end-to-end testing as you build out and configure out your Dynamics 365 solution is important. Performance testing, that can begin early with some isolation tests. And then you can steadily build out the performance tests as you get more confidence in the result. It's probably a good idea not to start go too crazy with the performance testing really early. You want to establish some good quality results, build a level of confidence in the parameters and the setup that you're using, because that can influence performance. So get some of those basics established first before starting on some of those performance tests. But then when you are ready to test for load and scalability, you can gradually ramp up the volume. For example, you might start at a 25% load and then move up to 50. It really depends on the feedback you're getting from the performance tests and the availability of data at the time. So I guess some tips here. Where you're doing lots of back-to-back test iterations. So this is where I might be running tests every 10 minutes or, testing on small sets of data, getting some feedback, running another test. You might want to consider changing this idle seconds before scale down setting. Essentially, there's what this does is it says, well, if this service is sitting here doing nothing for X number of seconds, then we should start scaling down. And that's good from a cost savings perspective. But if you're doing a lot of testing back to back, then you've got a wait time as the infrastructure is scaled back up or is provisioned. And just from some of the tests that we did, it may be anywhere from 5 to 10 minutes just for that infrastructure to provision again. So that can be some time saving there as an option. From a testing perspective as well, you want to test with different parameter settings and compare the results. So this is just an example where we've got an ETS model and we've manipulated that forced seasonality parameter. So for one, we've specified none. We've got multiplicative and additive. And as you can see, the colored lines are the actual forecast. The gray lines are the history. As you can see with those colored lines, we do get a very different result depending on what we set that parameter to be. So a really good idea to be comparing the different settings and to determine which is best for your set of data. Always important to use the right tools for the job. In this demonstration, we've used Excel and also Dynamics 365. As a data scientist, developer, they'll have different tools that they'll use for testing. Dynamics 365 is a good one for a business user or end consumer, as is Excel, but really consider the best tools for the job. This is another one that is interesting, where we've, from a granularity attribute perspective, you want to make sure you're not aggregating the results, the forecast results to validate. So what I mean by that is that we've passed to the parameter, the test. We're testing at a fairly low level this country and customer group, and we're getting an aggregated result of 120 forecast quantity. If I was to provide at that level, so this company site allocation key and item number, my forecast might come out at a different. So this becomes more apparent when you're looking at it over a timeline. It can look, you can get strange results when you aggregate versus looking at a lower level when comparing the history with the forecast. Performance guidance, AML compute is going to influence runtime. We've gone through some of this. As an example here, if you've got 11 nodes, one of those will be taken or used to run the script, but then we'll have 10 that will be used for the forecast script. If we're using a compute with 8 cores, we're effectively going to have 80 parallel worker processes. So that's important. The granularity attribute, that's going to determine the level of aggregation of the data. So that can also influence runtime. Again, it really depends on the volume of historical data, but typically if you've got really low level attributes such as customer account, you're going to have more forecast runs and it's going to equate to a longer runtime. In some of the tests that we've done, we've found that the time series model it's usually for large sets of data can impact the runtimes. So all is obviously going to run all the models and then pick the best. So that's going to take the longest, but ARIMA also seems to take longer than the others. Okay. There are lots of resources. These are just a few on this slide here. We've got a great docs page which goes into lots of detail. We've got a Yammer forum. I mentioned before, if you haven't seen the intro to demand forecasting, by all means check that out, because that will provide more context to this session. And on GitHub, you can find the template for Dynamics 365 demand forecasting. And that brings us to our Q&A. And do we have any questions that we haven't already answered?
No, we have no questions we haven't answered, but I do think there's one I wanted to come back and re-highlight. So I think just a point of clarification, since we have already previously had an option for using Azure Machine Learning to generate a demand forecast, and just worth revisiting that why we're here talking about Azure Machine Learning Service. Do you want to kind of give that background, Toby?
Yes, definitely. I think Andrey, you can probably add to this. But Azure Machine Learning Service is effectively superseding or replacing the Machine Learning Classic. So that had already reached end of life. So it was really time for us to align to the modern service. So that's why we've made the change. We will still continue to support the Classic for a period, but that was the key trigger for this change. There are other benefits that we get with the machine learning service as opposed to the Classic, and performance scalability is one of them, and definitely as a data scientist, there's more you can do with the new service. Andrey, did you want to add anything to that?
I completely agree that choosing Azure Machine Learning Services was natural because it's successor of Studio Classic, which is being deprecated. And in addition, it provides a great level of extensibility. So the way we generate the forecast can be fully changed, completely changed. That fits into overall model of high extensibility level of D365.
Right.
Okay. The other question that we already answered, but just to recap, we had a question: are R and Python the only languages that we can use? Can we use any Jupyter Notebooks language?
What was the answer that you provided?
Andrey, do you want to answer this one?
I answered that question. I can recap it. So, yes, can you hear me? It's definitely, I think it is possible to use other language, but someone who will do it might face some difficulties because, as far as I know, there is only Python SDK that provides API for Azure Machine Learning Service. And using other languages would mean that we need to basically call Python methods from different language, which would add to the complexity and probably performance.
Okay. Our next question.
So, yes, it is possible, but I would not advise.
Okay. Our next question is: how can we debug a modified R script? Toby, do you have any recommendations there?
So, I mean, if we took a look at the demo, any issues would surface in those error logs, but as far as a debugging process, I couldn't answer that one. Andrey, is there anything?
Yes, I was typically using RStudio. It allows line-by-line debugging process of R script.
Right.
And our last question: what is the date key in the historical CSV?
The date key is references a date. I'm Andrey. Do you know specifically I know it's an integer, but do you know specifically, or more specifically, what it is?
Yeah, I know. We are basically forecasting a time series. So date key is also like consecutive number sequence of integers, and it's basically the tail of implementation of D365, and it's taken from BI related tables, something like BI dimension. So basically, where we each and every date period has its own integer number, and it's easy to encode these date periods with just integer number because it's more or less culture agnostic.
So is that taken from a date dimension within Dynamics 365?
Yeah, exactly.
Yeah. Okay, we're just over time here, so we'll hand back to Brad to wrap us up. Thanks, Brad.
Thank you, Toby. To our audience out there, I've posted a link to a short survey in the Q&A panel. We'd like your feedback on today's session and to hear what you'd like to see in future events. Thank you for your participation. As a reminder, the recording of today's session will be available on the TechTalk's Community Dynamics page within 5 business days. And finally, I'd like to extend a big thank you to our presenters and audience for joining us today.